Again, Kelly Davidson, Viking Automatic Sprinkler. I have been in the industry a really, really long time. I've kind of floated inside and outside the industry. Some really great takeaways from the last session that I hopefully will address in this session. Some questions that had come up that I will hit on and hopefully make some clarity with that. But basically, my agenda for the day is go through the basics, kind of a quick overview of where we are today with fire sprinklers, some industrial applications and solutions that we already have in the market, and some newer technologies that are just emerging that are really changing our industry. So go way back in time to 1812. We've got Sir William Congreve installing the first, I would call it, manual sprinkler system in the Theatre Royal. The system was a network of perforated piping where if there was a fire, somebody would grab a bucket of water and fill the pipes with water. Obviously, we've come a long way since then. I would say that our industry over the last 5 to 10 years has accelerated at a blistering pace. Some industry facts. 51,000 fires are reported every single year, leading to 36 deaths. Only 10% of those are sprinklered buildings. Reason being is most homes don't have sprinklers. So that's why we have such a high death rate. Sprinklers are not required in most homes. Where sprinklers are installed, property damage drops by 90%. We have a death drop of 89%, and firefighter injury drops by 60%. So pretty staggering numbers. Can't look away from those. That's pretty significant. One fire sprinkler is typically all that is required or all that is needed to put out a fire. So that's how the industry kind of works. If you have a fire in this room, hopefully only one sprinkler is needed to put it out. Number one reason sprinkler systems fail is that they're shut off. I can't tell you how many facilities I have been in, specifically in the industrial world, where I've been told the panel was beeping. So why isn't it beeping anymore? We turned it off. So we've got a fire pump in a very large industrial facility on the North Shore with no fire protection. Is that what we're talking about right now? Yeah, no, we turned it off. How long has it been off? Oh, we don't know. So this does happen. It happens more often than I would like to talk about. So we're going to quickly talk about what is a fire. In every aspect that I talk about later, I may refer back to this in some form or another. Pretty simple. We have heat, we have oxygen, and we have fuel. That combination creates a chemical chain reaction. We cool materials, we smother air supplies, we remove fuel sources to put out fires. The last one in there is interrupting the reaction, and a lot of the detection technology that I'll talk about later gets into really understanding quickly when a chemical chain reaction is beginning to occur before a fire starts. All right, standard sprinkler system review. This is what we have in this building, dry systems, wet systems. This is the basics. So, wet fire sprinkler system. We have a water supply. We have our riser assembly. The OS&Y valve is a control valve. We have a flow switch or an alarming device. We have a local alarm that would go off if that flow switch went off. Fire department connection, so the fire department can pump water into our system. This wet system is completely full of water at all times. Inspectors test off the end here. That's how we test the system to make sure that we still have water at the end of our system. Dry sprinkler system, a little bit different components, mostly up here in the valve assembly. We do still need a heated enclosure for that water supply to come into the building. These pipes right here that are red are full of air. They're backed up by an air compressor. That air compressor holds back a clapper in a dry valve until that air is released. Typically that would be a fire fusing one of the links on the sprinkler heads. The air goes out, the clapper opens up, water comes in. Again, we have an inspector's test on the end, and there's a time delivery for dry systems. The key to a dry system in any building is about 40 degrees ambient temperature. That's what the code is going to say. Basically, if you're sitting at 40 degrees, you need to have a dry system in that location. All right, this is really, really pretty distribution center valve assembly room. This is the stuff that I look at and think, wow, that's really cool. So I know, my standards might be different than some of yours. So right on. So we've got a water supply right here. That's coming in from our loop, our, whatever it is, our water tank. This is the water supply coming into the pump house room, the pump room. Backflow prevention device with two OS and Ys. They're both going to have tamper switches on them, so you can't shut these off without an alarm going off. This next run of pipe takes you to your fire pump and your jockey pump. Jockey pump just maintains the pressure in the system if the pump, if there's any fluctuation. We have a bypass loop that goes around the fire pump. So if you ever need to take the fire pump out of service, you have a loop that goes around it so that we can do that, do those services on there and still have at least some water to the system. Test headers back here. I'll show you some pictures of that later and what we do with the test header. And these are all the wet systems that feed into this distribution center. Each one of these risers probably constitutes about 40,000 square feet of physical space that the sprinkler system is covering. So obviously it's a pretty substantially sized building for this amount of wet systems. On each you have a tampered valve, which you can shut each system off individually, a water flow switch, gauges, and a drain. On some of these you also do see a white placard here, and basically all that indicates is those are the systems that we used in our hydraulic calculations to determine that the system works. So a lot of times those are missing, and that's a really, really big issue with FM. So in your facility, if you do not have the hydraulic placards, it can be quite an issue. A little bit of reverse engineering needs to take place. Other things to take note, you have your own heater in here. These rooms, per NFPA, have to be dedicated to the fire pump assembly. So there are provisions, local jurisdictions that will allow you to do things differently, but for the most part, a fire pump room has to be a fire pump room, and that's it. Travis could probably tell you the ratings on a fire pump room. There you go. Some other types, fire sprinkler systems. These are ones I'm not going to hit on too much today, but again, these are basically what we see on a pretty much day-to-day basis. So an ESFR fire sprinkler system, early suppression, fast response, lots of water, giant pipes, big heads, big fire pumps. These are going to be in your warehouse occupancies. So warehouses, tons of different system design criteria goes into it. We have racking height, building height, what you're storing. So there's a whole chapter that I really don't like to get into in NFPA that deals with this specifically, down to racking width, and ASRS is a whole nother issue that we're starting to deal with as well with the ESFR systems. In racks, where our overhead protection doesn't really suffice in an ESFR situation, we may need to use in-rack fire sprinklers. And again, those are designed based on different criteria of what you're storing. Forklift drivers love in-rack sprinklers, and they're super popular with maintenance engineers as well. So we probably get more service work out of forklifts hitting in-rack sprinklers than anything else in warehouses. Pre-action systems. These are going to provide you a level of redundant protection. If you're protecting something like document storage areas, even data centers, fine art. So your pipes are going to be empty until you get one signal. And that signal could be a UV detector, a smoke detector, some other type of detection is going to tell you you might have an issue in this room. And when that happens, water would come into the pipes, but nothing is going to happen until that sprinkler head goes off. There's different levels of redundancy you can set up in a pre-action system. Dry ESFR, or performance-based design systems. These are specific to the frozen fulfillment centers and large cooler operations. There's a lot of criteria that must be met to use these systems. I will talk a little bit more about those in the future. The industry name that is kind of the tagline right now is Quell, but there are other suppliers of such systems. Standpipes, fire hose stations, they may be required due to height or remote locations. My tagline here, always good to check in with who is fighting the fire. They're the ones who should have the final say. Different municipalities are also going to tell you different things. City of Duluth, they want them on alternating where it says in the code because of how the hoses stack up and how they feel about it. So always great to check in with that end user on those situations. All right, now we're going to leave a little bit of the life safety behind us and talk about life safety and mechanical safety. Now we're into protecting equipment, protecting tanks, protecting other things that might have a special need. So right here we've got a great looking deluge system on a chemical storage tank, UV detection on the sides, 10 by 10 pattern or 10 by 12 pattern, fully coating the entire exterior of this chemical storage tank. At the end, I will talk a little bit about the Chemical Safety Board and their investigation of the Husky refinery fire. If you can imagine that this was going on, this is pretty accurate to that day and the sprinkler system's activation. So, deluge systems. Used in high hazard applications where an entire area needs to be protected. Piping is unpressurized with open heads. Multiple detection systems can be used from pneumatic to electronic. Really depends on, are you outside, are you inside, are you in a dusty location? UV, rate of rise cables, thermal cameras, aspirating detection, they can all be used to trip a deluge valve, just depending on what, like I said, what the actual environment is that you're having your deluge system in. Very high volume and very high hydraulic demand. Calculation of a deluge system, every single head is flowing at the full rate. So we don't have just a small area that we are flowing on our system. Every single head in that system is flowing at full flow. Couple good examples here. This is very typical of what we see and what we do a lot of. We have a bank of transformers here. Again, we have like a 10 by 10 spacing, completely coating the exterior of these transformers. Very high rate of flow, as you can see. And again, over here, same thing. We've got a piece of equipment that is completely being doused by water. So when I was talking about standpipes and fire hose valves and asking who's going to fight the fire, who was asked about these two? I don't know who's going to stand next to this transformer and hook a hose up to it. So that's where sometimes common sense leaves the room. But again, when we're talking deluge, we can also be talking about protecting equipment. And this is a pretty good video showing that, specifically taking care of these pieces of equipment. Every head is flowing. You can hear the amount of water. It is a very high rate of flow. That is obviously backed up by a pretty large fire pump. One thing to note here, one thing to note on that. Oh, now we lost it. All right, let's go back. All right, is at the end of that video you saw that some of the equipment was covered, and during testing, that is one consideration that we need to take into account. Some equipment can be damaged by the water. Some authorities having jurisdiction don't care. They want to see the test. So there's different ways that you can skin that cat. I've worked with many different organizations on how to protect their system or their equipment by coming up with some different solutions there. Not sure why that one's not coming up. All right, we're missing one video. I can tell you it was another test. It was actually pretty close to the test of the tank that we saw in the first picture. The reason I added that video in was to show the water flow and the pipe stands that are in place. And the pipe stands are basically just rocking back and forth under the pressure in the water. All right, gas suppression and clean agent systems. This will get into some of those questions that were asked when we don't have water. These are used where water would be damaging or downtime is acceptable. So I was corrected on this number today. $7.4 million per hour if an Amazon data center goes down. I was corrected to the point that it's $1 million a minute. So pretty significant. When you're talking about a gas suppression fire or a fire in a data center, literally you're going to get some cables that ignite, gas suppression system goes off, you go get a new rack, you slide the new rack in. The turnover is going to be pretty fast. There's no cleanup or a small amount of cleanup, so they can get back up and rolling very quickly. There's many different types of gas depending on what is being protected. We still use CO2. We still use halon in certain situations. Novec 1230, inert gases, all of these things depend on what you are protecting. In a simple data closet in a building like this, you may have a Novec 1230 tank no bigger than this pedestal. So it all depends on kind of what you're protecting. And the other two things to take into consideration, is it a total flood application or is it a local application? Total flood, again, that data closet, the entire room is going to be filled with that gas. Unless you're using CO2, these gases are not going to knock you out. They're not going to cause problems for the people working there. But there are room construction considerations that need to be taken into account if you are using a total flood application. Local applications, low pressure CO2 on transformer bearings and turbine generator bearings are still a great solution. So we can still use those. Big open areas, CO2 is directly placed locally and takes care of most fires.
Kelly, what's
Yeah.
the upkeep on this?
Good question. So if we just take, for example, these 3 tanks right here, feeding up to a control room, whatever it is. Every year, we're going to come in, we're going to do an annual inspection. We're going to test the alarms. We're going to test the integrity of the piping. We're going to pull these tanks off of whatever they're connected to and weigh them to make sure that the agent is still in there, the agent hasn't leaked, that those numbers are the same from the year before. So pretty much it's either an annual or a semi-annual inspection on most gas suppression systems, depending on the owner, authority having jurisdiction, or insurance company. Couple examples here. Just your standard gas nozzle here. The piping, stainless steel seamless piping is typically what we use because it is very high pressure, and these are high pressure fittings. We can use call it like a coupling or a Victaulic style system as well, but I think majority of the time we stick to the larger threaded fittings in most situations. Couple tanks here. We have a control room. I threw this picture in there because I think it's good to note that gas is very specific to the compartment that it's in. One of these systems is feeding this room. The other one is feeding below the raised floor. So we'll have a completely separate system that feeds all that cabling that goes underneath the floor. In each situation, we do have a fire alarm panel and a panel that is set up for the releasing and alarming. Basically, if there's a fire, we can go and release this automatically if we need to. And in most control rooms, you're going to have a pull station and an automatic release for the gas suppression systems. All right. We don't have enough water, right? Okay. Water mist systems are currently my favorite sprinkler systems that we have in our quiver right now. We're not doing enough of these. There's a boatload of situations where these are the right decision. They are still about the same cost as a gas suppression system. So we're still in that really high dollar pocket when we talk about these types of systems. But I think the best example that I have is we had a manure digestion project. They had a 2,000 square foot metal building that they were going to need to sprinkle due to the authority having jurisdiction. We gave them a price for a fire pump and a tank to protect 2,000 square feet. It's kind of ridiculous. And I said, why don't we give them a fine water mist system instead? So there are different solutions. These are used in water-sensitive areas, again, because we're not creating droplets, we're creating a fog. Data closets, lube oil, document storage, cruise ships, power, auto. We just finished a project for a large auto manufacturer in South Carolina, and these were all installed in the filter operation of the paint booths. The Notre Dame Cathedral in Paris just chose a fine water mist system to reinstall when they're going through their new construction. These systems use a mist to drop the temperature, and it almost works like a gas. It's going to disrupt that heat portion of the system, and it also knocks down smoke. So it's going to allow people that are in the building to get out of the building, much like a fire sprinkler system does. Uses high pressure water and special nozzles to create mist. Some of the other products that are in this lineup use nitrogen as well as a backup. They're pressurized either using tanks or pumps. You will notice that is a ton of pipe stands and a lot of unistrut. When we're talking about high pressure, we're talking about 5,000 PSI in some cases. So this stuff has to be buckled down tight. And that is one of talk about the expense. The hangers are one of the more expensive things that go into the installation of these types of systems. Here's an undisclosed location somewhere in northern Minnesota. You can just see the high level of fog here. It is just, impenetrable. You can see the nozzles just dropping fog down. There's multiple layers that come off of this one. This is based off of a very large fine water mist fire pump that was specifically built custom for this project. Again, lack of water, even lack of heat. You really don't need more than a 55-gallon drum of water and some electricity to get one of these systems up and running for a facility. Other nice things, there's no environmental issues that we're starting to see, and I'll talk about later. So there's no PFAS in water mist. There are filters inside the sprinkler heads themselves. So it doesn't have to be. It can be just city water. But yes, inside the heads there actually are little filters. So the installation process also goes through multiple steps to make sure that the insides of the pipes are very cleaned out. So yeah, there's other steps that are taken to make sure that what you're getting is a clean product. Explosion protection. Average dollar loss per incident is $3.4 million. They only equate for about 4% of actual fire losses in facilities, but 40% of all losses, 4% of interruptions. Used where powders are present in a confined space. Pharmaceuticals, woods, metals, ags, plastics, anything that has flammable dust. Material testing may be required or a dust analysis. Criteria for the type of explosion protection depends on material. If the material can be vented safely or if it needs direct suppression. So if you've got a product that can be vented out into the environment, it's safe for the environment, you may just want to do direct out to the environment. You can see the explosion panels on the side here. Explosion suppression, isolation, flameless venting, and explosion venting are all different types of explosion protection. Detection is based on sparks that come through the system and get picked up by UV detectors or pressure. And when we're talking about how fast some of these explosion protection systems work, it's milliseconds. So it's really has to be really responsive and really fast. Quick video. I like this video just because it shows a lot of explosions, and I thought that was important before we all had beer. So they talk in it, but I mean, just look at the explosions.
Combustible dust can be a problem in a lot of different industries. Food and beverage industry, pharmaceuticals, chemical, and many others, a lot of wood processing. Any carbon-based dust, and sometimes even plastics and metals, if they're in dust form, they're susceptible to explosions. Explosion suppression systems have to be very fast in order to do their job. From the time an explosion starts, and a tiny spark or whatever the ignition source is will light the suspended fuel, that suspended dust in the air. There will be a fireball that starts to grow and the pressure wave coming out of it as well. We use a standard pressure detector to monitor the explosions, coupled with a very fast controller, and we're taking a reading off of that pressure detector 4,000 times per second. Within a millisecond, when we see a pressure rise, we can make a decision of whether or not that is an actual explosion and react to it by firing off one of our output devices, a suppressant container, or closing different isolation barriers. We have to be very fast and work within milliseconds to prevent the explosion from spreading or creating an overpressure condition. FITE continually improves our explosion protection solutions through new product development. We do a lot of testing in our remote testing facility to understand the science behind explosions, and we can then create the products that best control and protect people against those explosions.
Well, the risk is absolutely real, and when you look to some of these events that have occurred in the past, these are human beings. These are people who've lost their life, who will never get to go back home to their family. And for us, that's unacceptable and it's completely avoidable. It's our passion here. It's our obligation to make sure that events like this are mitigated to the best of our ability. We employ some of the best engineers and scientists, I believe, in all of the world, and they are constantly working to try to make these incremental improvements that may not seem like much from a business standpoint, but it makes the product better, it makes the product more reliable, and at the end of the day, it will help us save lives.
All right, let's get some explosions. So, one facility that we work in northern Minnesota, they did have a dust explosion, and 9 people died. So it is, it's very front of mind when you go into that facility, you can tell that they've had an incident. That's a whole nother topic to talk about, but the minute I walk into a facility, I can tell if you've had a fire or not. So depending on how the facility looks, how the employees act, and that's one where they had to put blast panels around the entire top of the facility, so the building actually blows out now if there was to ever be an incident. Here's a quick little diagram showing just a spark detection in ductwork and how it works. If you can imagine your ember is floating down your ductwork right here. It gets picked up by these 2 UV detectors. Alarms go off, process shuts down, water gets directed to your extinguishing assembly. That duct or that piece of ember will keep floating and it'll hit a wall of water inside the ductwork. You'll know because your process shuts down. There's your ductwork's full of water and pouring all over the floor, and your alarms are going off. So, but nobody died, but you have a mess on your hands. I've been in a facility when that happened. All right, so here's one of the newer technologies that's really coming of age right now, and it's air sampling. If you can kind of think of it like this, you have a smoke detector in a room. That smoke detector just sits there and passively waits for a fire to bring smoke to it. Aspirating smoke and gas detection continuously samples the air. It's continually pulling air with a vacuum so that it can tell you before you have a fire if there's chemicals present in your air that indicate that you might be in a situation that could become a fire. When we go back to that fire triangle and we talk about the chemical reaction, these systems are sniffing for that chemical reaction. That's what they're there to do. Using them in more and more applications every day. Data centers, battery storage, power generation, very early warning system, catching fires before they break out. They can be set up to sniff specific chemicals as well. Natural gas, lithium ion, whatever the hazard might be, it can be programmed to just look at those chemical responses. Yes?
How does that work in terms of speed? It seems like you'd have to move a lot of air to a remote location to test it.
They do. They turn over a lot of air very quickly. So he asked basically a question about how fast is that smoke detection pulling the air in and getting to the detector, right? And it's a very fast process. I don't know the exact, the exact seconds, but they're turning over air very, very quickly to make sure that they're catching anything that could be coming. This is a pretty good example. This is an example that we're seeing a lot of currently. Call this your battery storage unit on the backside of a solar farm, right? What we've got here is, oops, sorry guys. We have our piping, perforated piping inside the unit, and it's also at each of the exhaust vents. So it can suck all that air out, travel its way back to this laser unit, which is checking for a specific chemical pattern or a specific chemical, and then it'll produce a Horn and Strober alarm if it's starting to see that. There's not much. There are ways to handle, like I'll call this a lithium-ion battery pack. There are ways to handle these fires, but they're evolving every day. So this is the best way to find out if you're going to have an incident early on. This one, it's kind of hard to see. We have a couple detectors up here, and they're just checking to make sure we don't have a natural gas leak in this facility. So we can set them up, however, for whatever issue or environment that needs to be detected. I don't know what fire protection talk would be complete without talking about foam. All right. Caveat. PFAS is a major issue. It's in the news every day. It is just like raking our industry over the coals right now. This is one of those situations that is being very, very affected by that. So it is still currently used in oil and gas, airline industry, and other highly flammable areas. Basically, if you have a product like oil that's going to burn on top of water, you're going to want to use foam for that because the foam is going to sit on top of that water as well and extinguish the flames. This industry is shifting right now in a major way, kind of led by the Department of Defense. The Navy was the first one to come out and say, in the last 40 years, we've lost more airplanes to foam than we have fires. So I could have probably done that math pretty quick without a whole lot of other people in the room, just knowing how many discharges I've seen. They're very expensive to install and maintain. They can be set up as either generators, which we'll see in a minute, or you can have a deluge application with open sprinkler heads. There is new foam coming out that is more environmentally friendly. And the latest that I have read is you can use what you have until there's an environmentally friendly resource. But seeing where the industry is going, I am thinking that if you do have foam in your location, you should probably start to think about how you're going to remediate that and get rid of it. There's a lot of different solutions to that as well. So the Navy is going to higher levels of detection and pre-action systems in a lot of the hangars. So they're just going to fight these with water. So here you go. So these are generators, and there's two components here. There's a fire pump that has water backed up to it, and there's a foam tank. They slam the foam and water together in a proportioner that gives you basically the mix of foam and water that fights the specific type of fire that you're looking for here. So we'll go ahead and watch. So 13 feet, that's the bottom of the wings. That's typically where they try to get the foam to. Fire pumps and tanks. Again, great conversation about what do you do when you don't have water. You can easily dump $1 million into a tank and a fire pump if you'd like. So we've got many different types. We have electric and diesel. We also have wells. I've used well heads on projects that we can't get an electric diesel power into. Diesels have a few extra requirements, and they're just, you know, they're made for a more specific environment than electric. If you can get the electric in there, go for that. There are code requirements that would want you to use diesel in certain situations. Different configurations, vertical turbine, horizontal, inline. Kind of depends on our space requirements, how much space you have in your building, what makes the most sense, what your water supply is. Those are all considerations that would be taken into place when you're trying to figure out what type of pump to use. They can be fed by a city water supply, a water tank, or a natural source. When we're talking about natural water sources, if we can leave the DNR out of it, we should probably do something different. This, however, is not a natural water source. This is a pond. This is a pond that was created specifically for this fire pump. So there's a fine line there somewhere in the sand. Tanks can be above ground, below ground, poured in place, many different configurations and materials. Bolted metal, fiberglass, plastic, or concrete. State of Minnesota used to let you use your pool as your water tank. Finland's Naskov School still uses their pool as a water tank. So it's been probably a bad decision after all the pipe we've replaced in that system. On the left here we have a diesel fire pump. Again, extra consideration. Diesel, you need a tank. You usually need containment on that tank. You need exhaust. You need batteries for startup. You need a diesel mechanic there on a yearly basis to change the oil. Every fire pump requires some level of testing, and it could be weekly, it could be monthly. It's whatever the fire pump manufacturer really deems is what you need to do. On the left or on the far right there, you've got a vertical turbine fire pump, and this is the shaft that goes down into the tank or the well. And that's the head right there. That's the power source. So this is a pretty good example. If we look at that vertical turbine fire pump we just looked at, it's going to get lowered down here into this fiberglass well and sits on top of a concrete pad. We've got a connection to our underground water tank. And underground water tanks do have a lot more considerations to take into account. Sure, they're great because you don't have to worry about them freezing, but we need an automatic fill, or not an automatic fill, just a fill. I usually recommend some form of extra fill. Hook it up to a well, hook it up to something else, because when you discharge that fire pump, you need to replenish that water within a certain amount of time. Some of that depends on a calculation with the fire department about how long it takes them to get to that facility. So that's always a negotiation of how fast we have to have that filled back up. We have a water kind of level monitor. Again, these should be made electronic and be fed back to a control room or fire pump room. Don't want to depend on somebody walking out there and looking down there to make sure you have enough water. You need to know if there's a leak right away. Access tanks should be checked, cleaned, maintained. I know that does not happen a lot. Other considerations, anyone out there on the civil side, dead men, strapping, and very, very specific requirements for compaction and lifts. So I can tell you from experience that's not a fun experience for somebody who doesn't know civil. So those were some long conversations. But again, typical underground water tank. If we're looking at, let's just call it an Amazon distribution center out in the middle of nowhere, these water tanks can be up to 500,000 gallons, 800,000. They're not easy to get, they're expensive. And you know, if it's gonna be sitting out on a concrete pad, you're gonna have to consider heat and insulation and a lot of other components as well. So a lot of gray areas are out there for water tanks. Good example of a water tank in a fire pump room. My assumption on this one is that it just feeds a distribution loop around a facility. Again, this looks like an insulated, heated tank. The funny story about that is I went rounds with a guy from Texas saying, well, I'm in Texas, I don't have to do that. But his ambient temperature, if you looked at his city, or the temperature that it can get down to, was 40. So it didn't matter. The code states that he needed to heat it, and he was going to go back to his fire marshal and get back to me. So I haven't gotten a call yet. So again, we've got access fire pump room here. That's that test header right there where we test the water, or test the fire pump. Fire department connection, you know, for this little room, you still have to have a fire sprinkler system in that little room. The one thing that's missing on this, and it drives me kind of nuts, is there's no horn and strobe on the exterior of this building. And it's on, you know, that just kind of grinds my gears. So there is a missing component to this facility here. All right, industry updates and new products. So PFAS and government regulations. Again, this is very front and center for us in our industry. Just yesterday, it was announced one of our distributors is filing for bankruptcy. They've been listed in 4,400 lawsuits relating to PFAS contamination. So when we talk about the industry shifting, they're shifting to new types of gas, shifting to cleaner foam, or shifting to water mist or other systems that don't have environmental issues that we know about. So the other parts of this are there's going to be a lot of foam remediation projects. We're looking at several RFPs right now for the military to pull all their foam out of all their facilities and replace it with pre-action detection or something else. So new types of detection, like we talked about, aspirating. Smoke detection is probably the latest and greatest. The other things that we have are UV and high definition cameras. That technology has just accelerated madly. We'll talk a little bit more about that. Antifreeze is still an issue, especially in our northern climates. There's nothing we can really do about that. We can put in dry systems where our antifreeze systems used to be, or we can continue just to saturate the concentration like we've done since we put the systems in. So not getting a ton of really great direction from NFPA or anybody else on that either yet. So I think everybody's kind of waiting for the first other person to, you know, raise their hand and say, we'll deal with it. Nitrogen generation, extending the life of dry systems. I don't think that we quote a dry system anymore without a nitrogen generation component as an add alternate. And I was really skeptical when this came out that it was just another gimmick, just another thing. And I've seen the results, and I have to say that if you're not using nitrogen generation inside your pipes, you're not getting the full life cycle out of that dry system. What we're doing is we're taking oxygen out of the inside of the pipes and replacing it with nitrogen. Oxygen is super corrosive to steel, and over time in that wet, moist environment, it'll break down a dry system very quickly. We're also seeing this in existing systems. Think about like a hotel attic system, riddled with you know, you can chase leaks from one to the next to the next to the next. Once you get caught up, if you can put in nitrogen generation, the leaks will stop. And we've seen this, and it works. So not a gimmick, actually highly recommended. And it is another component that has to be maintained, but it's well worth it in my opinion. Yeah.
You end up having to put a detection system in case there's too much nitrogen?
It does. So he asked if you have to put a detection system on there, and it has level monitors. So you know, correct. You'll know if it's not, you know, if your nitrogen, just like an air compressor, it's basically an air compressor that has a nitrogen generation component. So it just continually feeds that system. And you'll get a low pressure alarm just like you would regularly if something's escaping. So, lithium-ion battery, early detection and quenching. The coolest thing that I learned about in the last 2 weeks. So, rise in heat cabling. So basically you have cables that can determine, you know, the rise in temperature, 10 degrees, 15 degrees, whatever you want to set it to be. So in the EV battery market, pulling our EV batteries off the end of the assembly line, putting them on trays and racks, and it's all automated. There's these heat cables running all throughout this racking. If they detect that one of these trays is starting to have a rise in heat, they have that robot that put it there go back, grab it, pull it to a safe location in the facility, dump it in salt water, and they're done. So we've prevented a fire without ever, you know, having a fire. So those are some of the really cool things in our industry right now, where we're getting to the fires before they happen. Performance-based design, talked a little bit about Quell systems, pretty specific to the freezer distribution market, but they're outside of NFPA. The building construction is, and so certain companies have taken it upon themselves to do all the testing, get everything approved, so that we can be outside of NFPA and the industry can keep building larger and bigger buildings. I'm not going to talk too much about dry chemical applications. We do a lot inside of mining equipment and other applications, paint booths. That industry is pretty much, it is what it has been for years. This is the coolest thing, though, that I've seen in the last year and a half. When we talked about high definition cameras and UV detection. So on the left, we've got a high definition camera, and these cameras now can tell you what kind of fire you're having. It will be able to discern between a paper fire and a lithium-ion battery on fire due to the UV markers of that fire. So the best example that I've seen was a video that showed a guy welding, sunlight coming in, and the detection didn't go off until a guy walked into the middle of the facility and held a piece of paper up on fire. So it's the technology there. This is when I talk about acceleration of technology. This is where it has really taken off. One of the more popular waste management companies out there, maybe called Waste Management, is, is looking at a lot of this technology right now in their recycling facilities, specifically because of lithium-ion batteries getting thrown in the trash and starting on fire in their facilities. Now, next to this, we've got a water cannon, water or foam cannon. Nothing fancy, electronic. Here, right out of Star Wars, you have both of them combined. You have this camera telling you something's on fire right here, telling this water monitor to go put it out. So we are at the point now where a facilities manager can also say, holy crap, there's another fire right over here. On his phone, he can just kind of go, well, I'm going to point that over there and put that out. So now we've taken what used to be historically, let's wait till it gets to 155 degrees at the deck and fight these things before they get out. So pretty amazing technology. It's the stuff that we always thought was out in the future somewhere, and it's now here. There's other new technologies have hit with in hangars specifically, perforated concrete. So if you've got a fire, it's going to suck that fire down into the concrete. So a lot of new stuff out there, pretty cool. And just for fun, I'm pretty sure this Tesla is totaled. I don't know, but I'm pretty sure. From what I've heard in the industry, it's about 7,000 gallons of water to get you to this point. If your Tesla starts on fire, you're not getting much back. Again, when we were talking about the aspirating fire detection, here's those banks of batteries. Once you get to this point, it's called like a thermal runaway. There's nothing you can do. You can dump just water on it so it doesn't spread. But lithium-ion batteries are fire in a can. The energy's there. So there's not a lot you can do. Resources. I love answering questions. I love helping people with their problems. It's what I've done for a really long time. So if you do have a situation where you need some help, call me. National Fire Protection Association, Fire Suppression System Association, National Fire Sprinkler Association. Always check your local and state codes. Society of Fire Protection Engineers, FM Global, UL Lab, and then that Chemical Safety Board is a great one to go look at. They have some just great resources on there and some really cool visuals about how they do fire investigations in major facilities. That's it. That's all I got. I don't want to stand in between you and you anymore.
How about some questions for Kelly?
Might have missed it at the beginning. The PFAS, what is not environmentally friendly about that? I might just be oblivious
So it's
to
a forever. They call them forever chemicals, and I don't know the details of why. There's a whole family of chemicals that fall under that bucket, and the information is like literally day by day. So yesterday we're being told, well, some of them are good, some of them are bad. So it's a whole family of chemicals produced by 3M. That have been used in the industry for years, and they're showing up in soil, water, humans, animals. They're everywhere.
Can you use the mist system in the place of the foam system? If you have a solvent that rides on top of the mixture?
Potentially, yes. Yeah. I mean, we'd have to know exactly what the chemical is that's being protected and how big of an area. But I would say, yeah, that would be something that we could definitely take a look at.
I tell you what, Kelly, I thought you did a fantastic job.
Thanks.
Thank you very much. Let's give Kelly a hand.
Thanks, man. Good job.